Everywhere we look, we can see pieces of history, which could be one of the new 7 wonders of the world, the ancient Greek vase inside the museum, as well as the tradition of your village. All these things are part of a cultural heritage. Cultural heritage consists of the physical artifacts and intangible attributes of a group in the society, which are inherited from past generations and restored and preserved for the benefits of future generations. The physical artifacts include buildings, historical places, monuments, books, and works of art. These objects are significant to the history, architecture, archaeology, or technology of a specific culture. Moreover, archaeological heritage is a material record of past human activities. It constitutes an outstanding instrument for maintaining knowledge of the past and for emphasizing the cultural diversity that has emerged within any given territory over the course of history, irrespective of present-day political context. Its protection and proper management are therefore essential. Artifacts, without conservation, degrade and perish over time, leading to the loss of historical data. In order to avoid this degradation, specific treatments are applied. This could be either part of conservation or restoration. Conservation consists of the analysis, cleaning, stabilization, and documentation of the object. This step allows the categorization of the object and, at the same time, prevents any further degradation. Then, in addition to conservation, restoration can be performed. This consists of repairing damaged objects and replacing missing parts. Of course, restoration is not mandatory. Scientific studies are necessary to support both of these steps. In order to proceed with the conservation and restoration of ancient artifacts, it is important to know their characteristics, such as the materials, the techniques employed, and their age. This allows us to select the appropriate method of repair. In general, it has to respect the ethical principle in order to keep the artifact as close to its original condition as possible and for as long as possible. Cultural heritage objects are unique and irreplaceable, and consequently this requires the use of non-destructive techniques. And here is where nuclear techniques can help. Nuclear techniques, thanks to their great sensitivity and the possibility of discovering invisible features, have a potential for non-destructive and reliable investigation of precious materials such as ceramics, stone, metal, or pigments from paintings. Nuclear techniques started to be applied in the late 40s, when William Libby proposed the idea of radiocarbon dating, for which he earned the Nobel Prize in Chemistry. This technique has proven to be extremely useful for cultural heritage. Carbon dating allows us to determine the age of an object by measuring the amount of carbon-14 contained. During their life, plants, animals, and humans continuously accumulate the carbon-14 which is produced in the atmosphere. When they die, the quantity of this radionuclide in the body decreases with time. This allows for the determination of the ages of artifacts, up to 60,000 years. Nuclear techniques became particularly attractive when the requirement to preserve the samples became more and more stringent, since they do not consume the samples. All of the information obtained with these techniques help not only to repair damaged objects and give us the opportunity to categorize it, determine its age, origin, but also allows us to distinguish imitation from original as well. Indeed, nuclear techniques have become necessary complement for cultural heritage conservation, preservation, restoration, and investigation. The proper conservation of artifacts preserves not only the object itself, but also the archaeological data from field excavation and archival research. This allows us to completely categorize the object. How can nuclear techniques be applied to preserve the object? They can help to clean the object. As it happens with sterilization, ionizing radiation is used to disinfect wood, books, painting, and also mummies from mold, fungi, or insects. They can help investigate the composition of the object to categorize it, and with radiography to investigate its internal structure. Nuclear techniques can help preserve easily damaged materials. Irradiation can be used for in situ curing that, thanks to radiation-induced cross-linking, produces the consolidation of the piece through polymerization. Moreover, irradiation disinfects too. Let's consider a deteriorated painting, either on canvas, wood, or a wall. In order to restore it, it is important to know the techniques and material used to manufacture it. Restoration is supported by analytical techniques. One of the techniques for detecting elemental composition is X-ray fluorescence analysis, that in our case allows us to analyze the painting pigments. This technique exploits the behavior of atoms when they interact with radiation. The bombardment of the material with high-energy X-rays or gamma rays ionizes atoms, which then emit characteristic secondary X-rays, called fluorescent radiation. It is characteristic because it depends on the atom present in the sample, so it enables to identify which kind of pigments are present. Verification of authenticity can be done thanks to PISI's fingerprints. Indeed, all the raw material contains some micron constituent elements in very low quantities. These are related to particular places and ages, and thus can be connected to the author and the time period. The knowledge of the chemical composition of dyes can help identify non-authentic pigments. These change over time, so older pigments have different properties from newer ones. Moreover, previous repair that may have been applied to the original piece can be identified. Neutron activation analysis, another important nuclear technique, has been recognized as the method of choice for archaeological provenance investigations since the 1970s. It allows for the determination of the concentration of elements in a vast number of materials. By bombarding a material with neutrons, usually from a research reactor, the material is activated. This means that some atoms become moderately but temporarily radioactive and thus decay, releasing radiation. Measurement of this radiation during or after the treatment gives information on the concentration of the elements within the material. This is possible because the decay paths of many radionuclides are well known, and this allows us to identify which radionuclides are present by the spectra as well as their concentrations. Nuclear techniques have become an essential support tool for cultural heritage preservation, restoration, and investigation, and experts are necessary to effectively apply them and explain the results.